Hi everyone, this is Tom Kwong. Today I would like to share with you something about data wrangling techniques in Julia. Essentially, this is a session that I gave the Chinese community about a month and a half ago. And at that time, obviously, I tried to deliver the session in Chinese. And it was a conference, so I spent 45 minutes with the group, which was great. But I would like to share it with the broader Julia community. So today I am re-recording it. Number one, it's in English, so everyone can benefit from it. And number two, I have a bit more time than before because it's at my own pace right now. So what I would do is that I will split this session into two, okay? And the very first session, I will go over the presentation slides where I will talk about the data wrangling workflow and what the process looks like. And number two, what is the current state of the Julia data ecosystem and the tools that you have available, right, to do data wrangling stuff. And number three, I also have a number of slides that talks about some of the most commonly used DataFrames.jl functions. So that hopefully will give you some ideas about what's possible and what you can do with DataFrames.jl. Okay, so that's the session for today. And there's a second section where I will go over the some practical real world use cases. And I have prepared two data sets where I will go through the data wrangling work with them. So hopefully that will give you something more concrete to see. And then I have everything up on my GitHub repo, so you can also download it and try it on your own. So that's the beauty of open source. You're able to do the same thing as what I'm doing. So hopefully with some more practice, you will be very skillful in doing data wrangling work. So I hope you're going to be successful with that as well. Okay, having said that, let's just get started. So today's topic is data wrangling. And what is the definition of data wrangling? And I picked this up a while back. A lot of people talk about data wrangling with different expectations. For me, it's very simple. I like to be able to take raw data, perhaps something that's unorganized, and I'll turn that into something more useful, right? That's really the whole purpose of data wrangling, is to be able to get value out of your data. So the data wrangling workflow comes with these 5 different processes in general. So of course, the main thing is to be able to read your data from a different kind of sources, read that into your computer's memory, and then you can start wrangling them, right? So the first box is read. And then the next 4 boxes are clean, tidy, analyze, and visualize. These boxes, as you can see, are highly related to each other. I will be cleaning the data in such a way that the data will be easier to analyze on. I might need to tidy it up by reshaping it in different shapes and forms. And I need to be able to analyze it by doing some statistical calculations, potentially. And I would want to be able to visualize my data so I can get some insight out of it. And because all of these steps will give you additional value along the way, most likely you're going to be doing all these 4 things continuously throughout your data wrangling exercise. In terms of Julia's data ecosystem, I classify these into different phases of your data wrangling workflow. For read, clean, tidy, analyze, and visualize. So as you can see on the read box, for different kind of data formats, you typically can find different Julia packages that will help you get data into computer memory. CSV is a very commonly used format, and the CSV.jl package is a very high quality package that allows you to read data into memory very quickly, and it also has a lot of features. Parquet is a format that's used by a lot of the big data processes, and that file format is very compressed and efficient. I personally use SAS as my day job, and I had to have a library to read SAS files. In fact, several years ago when I started learning Julia, I converted a library that was originally written in Python. I converted it to Julia and called it SASLib. So that's actually my package. ReadStat is a similar package that also allows you to read data from Stata and as well as other statistical data formats. Of course, in the web scale, you will get JSON type of files, XMLs, as well as a lot of people are still using Excel. So sometimes you really need to be able to get data from Excel as well. So all these Julia packages all there to help you get data into your system. In terms of cleaning and tidying up and also analyzing your data, the main one that I would use is DataFrames. So DataFrames is a package that has been improved dramatically in the past couple of months. And it has now a lot of features for you to do all the work that we want to deal with in data wrangling. DataFrames Methods is a more convenient package built on top of DataFrames that will give you better syntax as an end user. So that may become more helpful as well. Although at the current stage, that package is still catching up to DataFrames because DataFrames is still kind of evolving at the moment. But very quickly, I would say after DataFrames Go 1.0, DataFrames Meta will come on board and very quickly as well. You can also see Query and JuliaDB are different kinds of query engine that you can also consider in using as part of your workflow. My recommendation is to stick with the basics, and DataFrames seems to have all the functionality that you may need today. Likewise, for visualization, you will see quite a few plotting packages. Plots is something that's very popular, and Makey is kind of like the new one that's also getting very popular because it makes use of GPU and allows you to plot very beautiful things, etc. Plus a few others that you may want to take a look as well. I personally is more familiar with plots and stat plots, so these are the packages that I will try to focus on today. Now, reading data is the very first step in the data wrangling exercise, and therefore it's very important for you to be able to learn the tools that are required to read data. And once you acquire the skills, it will make the rest of your data wrangling process a lot more, a lot easier, a lot probably simpler as well. And in terms of CSV.jl, when you read data from CSV, as you may already know, CSV file format is very free-formed, right? So sometimes you see there's a header field, sometimes there's no header fields. Sometimes you may see a period for missing data, and sometimes you may see an NA for missing data, or maybe some other string. And so because it's so free-formed, reading CSV file is actually quite complex. Luckily, CSV.jl automates most of it for you. So whether you want to skip your header or not, whether you want to be able to read the file with missing data, specific missing data string, CSV gives you all that functionality. And it's very feature rich. And so I would highly encourage you to take a look at the man page, take a look at the README and the documentation for CSV.jl, and understand some of the features that it provides you. Once you learn those options when you are reading CSV files, you'll be a lot more efficient as a data wrangler. Now, in terms of cleaning, what does that mean? Cleaning the data means that sometimes you may not want some of the columns. They may be superfluous, they're not useful at all, or maybe there's sometimes a rows that has a lot of missing data that's just muddy up your analysis. You don't want them at all. And sometimes the column names may be just kind of free form, and you want to clean that up and make it more consistent. Or maybe sometimes that when you read the file in, if the CSV package is giving you a data type that doesn't quite match what your expectation is, maybe you may have fixed that kind of thing. So, so that kind of process is very common. And over here in this slide, you will see that DataFrames.jl actually gives you quite a few tools to be able to clean your data efficiently. The first one is called Describe. It gives you a very quick way to analyze the data in your data frame. So it will give you the data type for every column. It will also give you the name of every column, etc. So just want to take a quick peek about your data frame and the distribution of your data. Describe is a very good function. The select bank function is mutating functions that you can see from the bank side, right? So when you use select bank, you can change your data frame in such a way that you can take away the columns that you don't want, or just keep the columns that you want, right? So there are two ways to do that, as you can see on this slide. And if you want to change the column names, it's quite easy. The rename bank function allows you to just change the column from one thing to another pretty easily. In terms of removing rows with missing data, the job missing bank function will come in handy, because you may want to just get rid of those rows that might have specific missing value for in those specific columns. So this slide, of course, doesn't have everything that you need, but I just want to give you a quick overview about what kind of cleaning that you might be able to do with some very simple functions that DataFrames gives you. Now, what is tidy data mean? If you look it up, there's a paper about that as well. Tidy data has 3 characteristics, which is listed here. And the first one is that every variable forms a column, right? And the second thing is that every observation forms a row. And number 3 is each type of observational unit forms a table. So it's kind of abstract when you read these characteristics. Maybe we can just look at an example, right? So I'll pull this out from a I don't remember exactly. Oh, there you go. It's the Zillow home value index. So I just downloaded it from the Zillow website. Okay, and so what you see here is that by region, you see New York, Los Angeles, Chicago, etc. By region and by date, right? You will have a Zillow home value index. So it looks nice and clean, but do we want is it really tidy or not? I would say no, this is not tidy. What happens is that, think about what is an observation, right? When you make an observation about something, typically you will observe that at the same time, right? And here, obviously, the dates are in columns, right? So every row you actually have multiple observations about New York, for example. The New York in the first row, you have multiple observations with that home value index. So in order to make it tidy, we need to make those values into rows. And the way to do it is, this is how you would see it, that by region, by date, you have a value, right? So now every row is an observation. because for that location, for that region, and for that date, you have a specific value, right? So, so this is what's being called as tidy. And sometimes tidying your data will make your analysis and maybe plotting easier. So how do you do tidy work? In DataFrames.jl package, there is a stack function. So the stack function basically allows you to take things that are in columns and transform them in such a way that they become rows. So you may have a very wide table, and you can turn it into a narrow table with more rows, right? But you can think about now. You can think of what happens to those. How do you distinguish column 1, 2, 3, and 4 when you turn those values into rows? So this is what's called a variable. So in this example, when I stack the data frame, I will take the I will keep the region name and don't touch it, right? And I will take all the rest of the columns and stack them and turn them into values, one value per row. And in order to distinguish every row for that region, I have to have a date column. So that's how you can see it here, right? So Aberdeen SD, you got 4 rows, and each row has a different date in it. So that's why date becomes a column. So anyways, coming back to the recipe here for tidying, you will see that you can also have different types of coding style. These 3 stack functions, they do exactly the same thing, right? So depending on how you think about and how you see the stack functions, whichever fit your style would be fine. And one interesting thing about doing the stack function is that it will turn the column names into a categorical array. If you come back to this screenshot, you'll see that the data type under the date column is cat something, right? The screen is a little too small to show what it is, but it turns out that is a categorical array, right? So a quick way to turn that categorical array into a regular date array, we can do a simple comprehension over here. This step, you may need to do it some of the time, but not all of the time, and it depends on how you're going to use the date column later on. I had to use the date column for plotting later on, and so currently the plotting packages, they don't really deal with categorical arrays very well. They don't handle it very well. So that's why I want to do this conversion and make it a date type. And sometimes I might want to just turn it back into a wide format. From the long format, I will just turn it back into a wide format. Why do I want to do that? Because when you have many rows in a very narrow table, it is possibly easier for the computer to handle it and to be able to analyze it. But for humans like us, looking at a wide table may be more appealing. So in terms of doing unstacking, I typically will use it when I need to analyze data more visually myself, right? And so that's what the unstack function does. Right? The line that you can see here basically reverts what we just did earlier after we stack the data frame. Sometimes we may have a column that will allow missing data, but of course, some of the times that maybe you already take care of your missing data, and the data type is still having the missing as a union type. In that case, it's a pretty easy thing to do to turn that column, in this case, columns 2 to column 5, to not allow missing, and literally it will convert the data type for that column from the union missing T column data type into a type T column type, right? So disallow missing bank is the function to do that. Now, analyze is actually the process that I really like to do, and that's the most fun part of data wrangling. Really, that this is the fun part. So because what happens is that you will get some insight out of it, and that's exciting when you are analyzing data. So couple of things came to mind about analyzing data using data frames. The select function allows you to look at only the columns that you're interested in. So maybe you have a very wide table and you just want to look at a few columns yourself, and the select function is pretty handy. And or maybe the second thing is that maybe you have a lot of rows in your data set, and it's very difficult to comprehend. And so what you want to do is sometimes is to filter your data into a manageable number of rows so that you can look at the data more closely. And the filter function does that. One thing to note is that the filter function here is an extension from the base package. And so unlike the other data frame functions, you will see that the data frame object is in the second argument, not at the first one. And the filter functions allows you to do apply a specific function, and once you apply that function to values for specific columns, you will be able to see the data that satisfy those predicate function. So in here you can see the region name, as long as it matches the Eberlin Texas string. As long as it matches that exactly, then that row will be retained and you'll be able to see the results. Likewise, the next one is greater than 400,000, and it basically is a function that will be applied against the values of the date column 2020 January 31st. So this syntax may be a little bit confusing for some people who are not familiar with pairs. So what happens is that when you see this equal sign with a greater than sign, that's an operator in Julia, and it will construct a data structure called a pair. A pair is basically contains the first part and the last part, right? So you got two things, they form a pair. And in this case, you will see that the pair consists of the region name being the first part, and the second part with the double equal sign with a string, that return an anonymous function. In fact, it's a closure. So it captures the value Eberlin Texas. It captures that string value and make a function out of it. And all that function does is that it can take it can take an argument and compare that argument with the string that's just captured here, right? So the second part of this pair is a very simple thing. The contract is that it has to be a function that accepts a single argument. So that's how filtering works. For sorting, there's a sort function, and this is very basic. If you just want to sort one column, you can just put the column name as the second argument. And the reverse sorting, you just descending if you want to sort in descending order, you pass the reverse keyword argument equals true. You can also sort by multiple columns when you put the column names in an array. It's not being shown here, but you are very encouraged to try that as an exercise. Okay, so another analysis work you can do is to do the transform. So what does transform means? So put that in your head. Okay, transform means adding new columns. All right, so to transform a data frame, you basically use this syntax. Okay, the second argument is basically a pair of pairs, right? You can see that arrow, the equal sign greater than sign together, that operator is a pair operator. But forget about what exactly how the data structure is being represented. You can just look at the direction of the data flow. Okay, So the way to read this transform function is that I will take the region name from this data frame, okay? And for each row in this data frame, I'll take the region name value and I will pass that to the length function, okay? And the result of that function, the length of the region name, will be saved as a new column called region name length, right? So it's a very simple way to apply a function across the row in that data frame. I would like to tell you that there are many ways to use transform. This is only one example, and when we have time, we'll get to the other more more interesting kind of transformations. And another thing that you would like to do most likely is to be able to group your data, right, and do some analysis on it, right? So what happens if I want to group all my data in my data frame by date, and then for each date, I will find, for example, in this case, the mean of the column value, right? So so group by allows you to create what's called a grouped data frames object, and then with that object you can combine everything together after applying some aggregation functions. So so in this example, you can see I want to group by date and then calculate the mean of the value column and turn that into a new column and name that as AVG, average. One thing that's kind of convenient, if you do a lot of this analysis in the repo, then the pipe.jl package allows you to build this kind of transformation pipeline. Basically, you can take a data frame, you pipe it to the next function, and in the next function, whenever you see an underscore, that underscore will be replaced by the result of the function that was called right before the pipe operator. So in this case, you will see the SDF data frame, because it's just an expression, it will be passed as the first argument of the group by function, because you can see an underscore over there. And then the result of the group by function will be passed into the first argument of the combine function, where you see the underscore. So because this is just a bunch of pipes with multiple functions in it, when you type this on the repo, it's really just a single command, right? And so it's somewhat handy that when you do a lot of work in the repo, you can build your pipeline, try different things, and then every time it's just one single command, right? And we'll do a lot of that later, and you'll see what I mean when we go through the demo. Now, other things that I want to talk about, very simple over here. The data frames also implement a lot of join operations. If you're familiar with database, relational databases, and SQL, you will find this very familiar. There are different types of joins in a relational database, and you can do the exact same thing with DataFrames.jl. So things like inner join, left join, right join, outer join. So those 4 joins are very common. Semi-join and anti-join may be a little bit less common for people who are not familiar with that terminology. Semi-join is basically a select from your left table. So in this case, it's the DF, the data frame. But only select rows from the DF table as long as the country table, as long as the keys in that DF data frame also exist in the country data frame. Okay, and so if you think about that as in the SQL language, this is kind of like select something from DF, where the keys of the DF exist in the subquery where you want where you select the keys from the country table. So that's what semi-join is, basically a select with a condition with a subquery. Anti-join is the opposite. You only want to select rows from the DF as long as the key does not exist in the country data frame. Right? So now the visualization is also a very interesting part, because you can see all that stuff, do all that analysis using transform, select, filter, etc. In the repo, but they are all in text, right? And a lot of times you can find more insight when you see your data being plotted as a graph. So there are many plotting packages. I personally is more familiar with plots.jl and statsplots.jl. And there are very common plots available, like the plot function will give you a line graph, scatter function will give you a scatter chart, histogram, heat map, a bar chart, etc. Plots.jl gives you very basic plotting functionality. A lot of times if you're dealing with statistics or you want to do some more fancy plotting with your data, then there are several other packages that helps you with that. Statsplots is one of them. For example, you can have a bar chart with categories that are grouped together, and maybe you would want to see a correlation between your variables for a time series. In that case, a correlation plot will be useful, etc. So there are quite a few different variations in it. Okay, today we'll explore some of these charting and plotting capabilities. But this is a very large topic. It will probably worth another video later on if you really want to. Okay, so the last thing that I want to tell you is that there are tons of documentations and training materials on the internet that you can learn more about DataFrames.jl. And the official place for DataFrames.jl documentation is a good place to get started. And so it's written in a pretty easy to read format, across different types of operations that you might need. And besides this, one thing that I want to share with you is that from the same author of DataFrames.jl, there's a repo on GitHub that talks about Julia DataFrames tutorial. So this is a very handy place that I always come to get some quick answers to how to do certain things. For example, any columns related operations can be found in this particular Jupyter notebook. Okay, and it's very easy to follow. I'll just let it render in a little bit, and it has some very simple example, and it gives you all the operations that you can do as related to columns of a data frame, right? So this is a very handy place. Jupyter notebook style, you can download it and run it yourself. Okay, and again from the same author, he has this channel go under the Julia programming language channel, and this is a specific playlist where you can get an introduction to DataFrames.jl. It looks like about 20 to 30 minutes long, 6 sessions. So I'm sure you can get a lot out of it. The other thing that I found was also very useful, and I attended this workshop at JuliaCon 2020. And again, from the same author, right? So he's very busily creating these training materials and share with everyone. This is a deep dive into DataFrames.jl's indexing syntax. It's a very interesting topic, and if you look further into how indexing works, you can get a lot of efficiency out of it. So this is probably not the last thing that's done by the same DataFrames.jl author, Wrangling, Kaminsky. So he's got a number of blog posts. If you start from somewhere around the May timeframe where 0.21 was released, he's been writing various topics as related to DataFrames.jl. For the most part, he's also an expert in agent-based modeling, so he's got a few blog posts about that as well. But in a nutshell, you will see that there are many, many tips available as related to data frames. The very last resource that I want to share with you is the DataFrames.jl cheat sheet that you can find on my website, rsmart.com. And then if you go to this data wrangling with DataFrames.jl cheat sheet, you'll be able to download a PDF file that contains a lot of the basic functionalities that you will find in DataFrames.jl. And this is only 2 pages, very easy to read, very easy to reference. And so this would be a pretty good resource if you like a cheat sheet style of reference. So I would hope that you would utilize this resource as well. Okay, this is it for our very first session as related to data wrangling techniques with Julia. I hope you enjoyed the session so far. In the next video, I will share with you how I apply some of these techniques for 2 real-world datasets. And I hope you can get some insight out of it and be able to apply the same skill to your own datasets. See you next time. Bye.